I went to Essex University at the end of the 1960s, when it was then one of the so-called new universities. And in those days, there was a feeling that we ought to break down the barriers between the different disciplines. And so they had a common first year in the social sciences. You didn't specialize more until you'd had some experience of economics and politics. I think they called it government and sociology. But there was no psychology in that bundle. And if you looked around the country at that time, there were very few joint degrees in economics and psychology. In fact, Essex now does have such a degree, recently set up, I think, but not Cambridge, as far as I know. The only thing I could find at Cambridge is that there was an economics and psychology reading group, but when I looked to see what they were reading, it was a blank page. Well, that's kind of symbolic of the parting of the ways that occurred in the history of thought. And I haven't got time to go into it today, but the next speaker, Bob Sugden, together with Luigini Bruni, wrote a very good, very readable paper published in the Economic Journal. I strongly recommend it to you. Now, the essence of it is that at one time, economists and psychologists were interested in real, actual human decision processes. But then economics evolved, maybe you'd say mutated, to substitute what people are like by what they would or should be like if they conformed with some kind of narrow notion of what's defined as rationality. And although it's a bit of an oversimplification, perhaps, economic man's head was filled with axioms and functions and unrealistic optimization, and the gaps between these models and actual behavior were often plugged with some econometrically convenient white noise term stuck on to sort of mop up what was left. And in the area of decision-making under risk and uncertainty, the version of this that became the conventional model was the expected utility model developed by John von Neumann, who was a mathematician, and Oscar Morgenstern, who was an economist. And this was sold and very enthusiastically bought by the economics community on the strength of its supposedly self-evidently appealing axioms and its seductive simplicity. It boiled down to the idea that people's choices between risky alternatives could be organized by assigning utility index numbers to represent the subjective value of payoffs and weighting these by their respective probabilities, and supposing that choice and valuation of options operated according to the weighted average or expected utilities. So whether you chose G or H in this case would depend on whether 0.58 times your subjective value of £19 was greater than or equal to or less than 0.34 times your subjective value of £37. I'm setting the utility of 0 here at 0. Now, once this model had been produced back in the 1940s, clearly there was an opportunity for testing it and trying to estimate the functional forms, although in the early days, there wasn't that much testing from microeconomists themselves. It was more from psychologists and statisticians and one idiosyncratic economist whose reputation was more in the macro field. I'll come back to him. But there were two main lines of inquiry. One line of thought was that if people acted according to these utility functions, then maybe we could ask them a bunch of questions, and on the basis of their answers, maybe we could estimate each individual's utility function. And then in principle, it's a bit like we've captured and bottled their decision-making spirit, and by reading off from the functions, we can predict what they'll do in choices that they haven't yet seen. And I'll come back to that approach. The other approach was to test some of the implications of the theory. So enter the idiosyncratic macroeconomist, as he was at the time from France, Maurice Allais, who constructed some options and asked a few people to make some choices and argued that the choices they wanted to make were inconsistent with at least one of the key axioms underpinning expected utility theory. And then there were quite a lot of others subsequently doing experimental tests of various kinds. I've given a selection of references here to some of the more influential studies in the 1960s and 1970s, and I'll come back to these shortly. But first, let's look at the decisions that I asked you to make. Let's look at this one. You were asked to say whether, if you were given this choice, which of the two options you prefer to play for real. Now, according to expected utility theory, the choice that you make reveals the relationship between your utilities of £40 and £30. If you choose L, it means that a 0.8 weight on the utility of 40 is bigger than a full weight of 1 on the utility of 30. And it's the other way around if you choose M. So you can check your own response, whatever you wrote down on your piece of paper, and hold that in mind while we look at another decision. But first, just to say that when you ask this choice in experiments and there's those real sums of money involved and the uncertainties resolved in the way that I told you about with the bags, the great majority of people who take part, usually about 70 or 80%, will choose option M, the £30 for sure, over the riskier option L. So here's another choice that I asked you to make. And again, we can figure out on the basis of expected utility theory what the implications would be for your choice. Now, for this kind of choice in experiments, the majority of participants choose R, the £40 option. Interesting to know if you did the same thing. Unfortunately, technology doesn't allow us to collate all of the answers, but there's a pretty good chance that you did on past experience. So now let's bring back the previous choice. If you did what many people do and you made the choices highlighted in red, M in the first pair and R in the second pair, then it constitutes an inconsistency with expected utility theory. This might be even more obvious on the next slide. The gold discs are next to the two most common choices. You can see that if we ignore the zeros, the expected utility of S is 1/10 of the expected utility of M, and the expected utility of R is 1/10 of the expected utility of L. But that means that if M has a higher expected utility than L, then 1/10 of the expected utility of M must be bigger than 1/10 of the expected utility of L, so that S should have a higher expected utility than R. But contrary to that, a great many people choose R as well as M. And this violates expected utility theory. It can't be explained away as white noise or as random error, because there's another way of departing from expected utility theory, which would be to choose L from the LM pair and S from the RS pair. But very, very few people do that. The violations nearly all stack up in one direction. There's something very non-random going on. Expected utility theory is being systematically contradicted in study after study using choices like these, which Kahneman and Tversky's 1979 paper, prospect theory paper, called the common ratio effect. Now, they published their paper in 1979, proposing this alternative called prospect theory to explain the patterns of choice amongst other systematic departures from expected utility theory. And part of their explanation was the underweighting of high probabilities other than 1 and the overweighting of low probabilities other than 0. And this diagram shows several estimates of functions that transform probabilities that are shown on the horizontal axis into subjective decision weight shown on the vertical axis. And these functions here are more to do with a later version of prospect theory called cumulative prospect theory, but the idea is essentially the same. And so if you apply this to the choice between £30 for sure and a 0.8 chance of £40, you can see that it underweights the 0.8 compared with certainty, and that favors the certain option M. But when you apply it to the other decision, both probabilities are overweighted, and the ratio is much closer to 1, favoring option R much more. So this non-linear inverse S underweighting, overweighting transformation of probabilities fits the observed patterns of choice much better, but it contradicts a fundamental principle of expected utility theory, which is to use the probabilities themselves as the weights. Now, that's not the only possible explanation. Another one that Bob and I were involved in developing, along with someone called David Bell, is what's called disappointment theory. The essential idea is that when people look at an option, they form an expectation about it, but they might also anticipate how they'll feel after the uncertainty's been resolved. Now, with M, there's no problem. If they choose it, they get just what they expect. But when they think about L, they might have quite high hopes because it's an 80% chance of £40. But on the other hand, they might end up with 0. And if they were to play that out for real, and if one of the numbers between 81 and 100 were to come out of that bag, then their hopes and overall expectations are dashed. They not only end up with 0, but on top of that, they have the negative feeling of disappointment. And avoiding that, anticipating it and avoiding it, favors choosing M. Whereas if you look at these two, well, you don't really have much hope at all. If this comes up as the question which is being played out for real, here, your expectations are pretty low. But if you do end up getting lucky, then you might not just get the money, but also the elation of having exceeded your expectations, and to a greater degree if you get £40 rather than £30, and this pulls you towards R. Notice that this explanation doesn't mess with the probabilities at all. It's all to do with the extra positive or negative utility from how your outcome compares with your expectations. And when you put the two problems side by side, although they aren't side by side in most experiments, but when you put the two side by side like this, then there's another possible explanation, which I'll describe very briefly as the dissimilarity versus similarity in switch of attention argument. Ariel Rubinstein's story was that when you look at L and M, you can see that they're pretty different, both in terms of payoffs and of probabilities, and you weigh the pros and cons, and conventional levels of risk aversion might tip many people towards M. But then, when you look at R and S, the probabilities here look pretty similar, 8% and 10%, 92% and 90%. Not much here to discriminate between the two options in terms of probabilities. So to make a decision, you switch your attention to the payoff dimension. And here the difference is clearer, and you go for the higher payoff. So you pick R. And again, that would give you the combination of M and R that we so frequently observe. Well, that's just a sample of the many models that have been developed to explain the patterns that Kahneman and Tversky called the common ratio effect. And if you read their 1979 paper, which I do recommend you do, you'll see a whole string of other effects that contradict expected utility theory. And the many other alternative models aimed at explaining these things show that there are many possible considerations, multiple explanations, and they're not mutually exclusive. And collectively, they provide much richer accounts of how people actually process and evaluate choices between risky options, how the brain is working with a variety of stimuli on a variety of levels. But in order to keep to time, let me turn to some other decisions I asked you to make. A study that I did with Gana Pogrevna a few years ago put exactly this choice that I asked you to make to 184 students from the University of Warwick. And you can see how your choice compares with theirs. We found that in our study, 144 of the 184 chose J. And in fact, for reasons to do with testing the consistency of people's answers, we put these questions to people 8 times in all in the course of the experiment. They were interspersed with a whole lot of other questions. And 127 of those 144 people chose J on all 8 occasions that we presented the choice to them. So it looks as if they really prefer J over K. Then we also asked them to put a sure money value on each of these, as you were asked to do separately. So look at the sure amount D that you said was equally desirable to you as T, which is of course the same thing as J, and look at what you said for E, which is the sure money value of V, which is the same thing as K. So now ask yourself if the values that you gave for T and V are consistent with your choice. Don't panic or be embarrassed if they aren't, because the great majority of people in our experiment chose J, but put a higher value on V, which is the same as K. Here's a summary. So in our experiment, we asked the valuation questions 4 times each, and we took each person's median value to avoid distortions from the occasional outlier. So of the 144 who chose J, 117. Sorry, I'm getting stuff coming through on my headphones from people. Okay. So of the 144 who chose J, 117 put a strictly higher median value on K. So a massive difference between the preference that they're exhibiting when they choose and the preference that they seem to be revealing when they put certainty equivalent money values on these two things. And this is a pattern called the preference reversal phenomenon. It goes back originally to the psychologists Sarah Lichtenstein and Paul Slovic in their 1971 paper. But here is a quote from a paper by David Grether and Charles Plott, economists at Caltech, who followed up this work from the psychologists. And you can see how alarmed they were, even to the point of melodrama, I think, where they say, it suggests that no optimization principles of any sort lie behind even the simplest of human choices. And at the end of the paragraph, they admitted that they set out, look down at that bottom sentence, they set out to discredit the psychologists' works as if they were works of the devil. But that was what they said at the beginning of their paper. And this is what they said at the end. To their surprise, despite doing the experiment correctly as they thought of it, and despite putting in real money incentives rather than hypothetical incentives, the preference reversal phenomenon persisted, just as it did in the experiment that Ganner and I did, just as it does in many other preference reversal experiments that people have done over the years. But a lot of the models that have been offered to explain the common ratio effect and the other things in prospect theory, including prospect theory itself, couldn't explain this preference reversal phenomenon. And that required other models and explanations. For example, there was one that Bob and I published in 1982 in parallel with David Bell, who also published in 1982. Briefly, regret theory says that you don't care just about what you end up with as a result of your decision, but you may also care about how the thing you end up with compares with what you could have had if you'd have taken another of the options available to you. And if it turns out that you end up worse off than if you'd chosen differently, that may be a source of uncomfortable negative feelings of regret that you should take into account if you anticipate them. So if you think about setting the certainty equivalent of T at D pounds, suppose as a first thought you consider setting little d at 10 pounds, then you may think about what happens if you don't sell, and if you play out T instead, and you happen to end up with 0, and you think that in order to avoid that and be more likely to sell, you should ask for a bit less than 10 pounds, and that thought might push little d down. The other comparison between 12 pounds and little d is a much smaller difference, so it's the 0 versus d that has the bigger potential regret effect and may push d down. But now look at the other valuation that you did and think of setting little e at 10 pounds. And now the big difference is between 50 pounds and that 10 pounds. Imagine you sold V for 10 pounds and then you watch V being played out and think how you'd feel if a disc between 1 and 25 is drawn and you could have had 50 pounds if you kept V. So that might make you ask for a bit more than 10 pounds, pushing little e up. So it's possible for someone to have a preference for T over V in a straight choice between the two, but to feel different pressures when asked about valuing each of them separately. These comparative judgments may operate differently in different kinds of tasks, so that straight choices may operate differently than separate valuations. Now, there are other models that also offer explanations of the preference reversal phenomenon. Schmidt et al., and one of the et al.'s is Bob Sugden, do it by changing the reference point. Bordallo et al. Do much the same thing as regret theory. They pretty much have all the same predictions as regret theory, but instead of modifying utilities, their model says that people pay more attention to big differences, and that has the effect of increasing the weights. That is, they transform the probability. So it's as if you weight the first column here at more than 0.25 because of the bigger difference there, and that attracts more attention and more weight, and you reduce the relative weight on the second column. So those models I just discussed were produced by economists trying to some extent to incorporate psychological considerations into an economic way of modeling. Psychologists tended to focus more on modeling which didn't so much assume set preferences that just pop out when the questions are asked, but which think more about the process of arriving at a response, how that process is influenced by the task. So a choice task might prompt people to think more about the probabilities of winning at least something. And here J's 80% looks a lot better than K's 25%. But when you give me one of these on its own and ask for a response in the form of a sum of money, you kind of prompt me to start with the money payoff and then adjust it down to allow for the fact that it isn't certain. But starting from £50 may mean that I end up with a higher response than for the other option where I start from £12. So this is what psychologists have called a failure of procedural invariance. Economic models have tended to assume that a particular model fits all, that it gets applied to every kind of decision, choice, valuation, ranking, setting probability equivalents as you did with P and Q, all done with the same system. That's the idea of procedural invariance, but that's what the psychologists think fails. And they allow for the possibility of what you might call different horses for different courses. And so these models suggest that there are even more diverse factors than the ones that I listed in relation to the common ratio effect. And so there's a process, and to pursue the process theme, I'm going to go back to Mostella and Noji. Now, they did a lot of things in their study. It's quite a complicated study, but I'll focus on just one, where each participant was offered the choice of accepting a gamble and maybe winning some amount, but maybe losing 5 cents of their own money. And although you might think 5 cents is nothing, remember this is 1950 or thereabouts, and 5 cents wasn't such a trivial amount then, 70 years ago. Or they might win some money. And the amounts that they could lose were always 5 cents, but the amounts that they could win were varied, and the different options were repeated, interspersed with lots of other decisions. So each decision in this case was repeated 14 times. That is 14 times with 9 cents and 14 times with 12 cents and so on. And here's a graph of the responses from one particular participant with the win amount on the horizontal axis and the frequency with which he said yes to the gamble on the vertical axis. Now you can see he always turned the gamble down when the winning amount was 7 cents or 5 cents. And he always accepted the gamble, played it, when the winning amount was 16 cents. But in between, it sometimes went one way, sometimes went the other for amounts between 7 and 16. So a range over which his preferences were not totally consistent and deterministic as conventional economic models generally suppose, but rather probabilistic, although in a pretty regular way because the chances of accepting the gamble rise as the winning amount gets bigger. But Mostella and Noji noticed something else, and it's pretty remarkable considering it was done 70 years ago with pen and paper, but they noticed that reaction times varied in a systematic way. When the winning amounts were such that people either always accepted or always rejected, they made their decisions pretty quickly. But when the options were more finely balanced, so that sometimes they went one way, sometimes another, they often took longer. And this is strongly suggestive of a process of arriving at a response rather than just consulting your preset preferences and plucking the right answer out. And such response time patterns have been confirmed many times since. With computerized experiments, it's much easier to do. Plus other methods like eye tracking can give us insights into the way that people move their attention from one feature to another and make comparisons and linger longer on some items than on others, all perhaps suggestive of people collecting evidence and constructing the case for deciding one way or another. And some psychologists have modeled the mental process involved in judgment tasks as different kinds of sequential sampling or accumulator models. And Busemeyer and Townsend applied this idea to risky choice in 1993 in the form of what they called decision field theory. Now, to give a general overview of the idea, different models do it in different ways, tweaking the assumptions, but it's as if you start with no prior information and then you look at different features and you see how these register as arguments, either favoring option A or favoring option B, and you update your current sort of balance of the forces of the two arguments. And as this updated balance moves along, you continue sampling until you reach such a weight of evidence in one direction or the other that it passes some threshold that you feel is big enough so that you can stop spending any more time thinking about it and sampling and just make your decision and register your response. So the more evenly balanced two options are, the more there'll be vacillation up and down, and the longer it'll take for you to make a decision. On the other hand, if the arguments all seem to quickly stack up for one option or the other, and then you decide quite quickly. So the response time, the reaction time, is often an indicator of the extent to which the two options are considered by you to be evenly balanced. And what this means is that if you present the same two options, exactly the same things, but on different occasions, and that can be different occasions inside the same experimental session, just a few minutes apart with other questions in between, the sampling and accumulation process might take different paths, even though the underlying sets of possible values and perceptions that you're sampling from may not be changing, just that you're sampling them differently. So if you ask the same question on 5 independent occasions, you might get something like the patterns that are shown here, with 3 of these streams of accumulation ending up at the top threshold, signifying a choice of A, and 2 down at the bottom signifying a choice of B. So this is consistent with the kind of probabilistic choice that Mostella and Noji observed 70 years ago, and that's been observed many, many times since. And what it means is that behavior is not an error or a mistake in these cases. It's an intrinsic process of variability, an intrinsic brain process. And you could write a program which has built into it some degree of randomness in the process of sampling, but keeps fixed the stuff that you're sampling from. And you can produce these kinds of patterns through simulations, which are not making any mistakes. They're just sampling. What that means is that if it's right that sampling and accumulation are the key to decision making, then things that influence the process can affect where you end up. For example, there might be a different sampling process primed by whether you're asked to make a choice between 2 options where all the parameters are being given to you by the experimenter, compared with a valuation task where you have to produce a value yourself to match the option that was devised by the experimenter. And if you're given a reference point or some endowment, that might make a difference. I mean, especially perhaps when you're dealing with unfamiliar or difficult things where people don't have a lot of experience to draw on. If you were asked in a survey, for example, how much you'd be willing to pay in extra council tax to put in 10 more miles of cycle lanes in your neighbourhood, or how much national tax you pay to reduce your annual risk of death in a road accident from 3 in 100,000 down to 2 in 100,000, where would you start? And where would you end up? And would the survey get a better answer by asking you a valuation question, what are you willing to pay? Or a series of yes, no choice questions, would you pay this, would you pay that, would you pay something else, iterating towards a final answer? Is it possible to say that one of these procedures, since all responses are the product of some kind of procedure, that one of these procedures is somehow more true to the underlying preferences than another? So I'm going to finish by asking what the implications might be for modeling and for testing. Much economic theory has wanted, really, to have minimal assumptions and to place restrictions on the richness of the processes that might be involved. It's looked for precision. It's used mathematical tools. It wants consistency, one model fits all, so that you have invariance across different kinds of tasks. It wants people to fully process the stimuli in front of them and supposes that the decision rule is optimizing something, even though optimization for things that are a bit more complicated than those gambles is really a very demanding process, and people have got other things to do. They can't spend phenomenal amounts of time on any one particular decision. They've got to make a decision and move on. And to the extent that these models don't fit the data, economists have tried to sort of plug the gap with noise or error terms, rather than the idea that this variability might be intrinsic and that precise preferences don't exist, that people's preferences are imprecise and often imprecise to different extents in different contexts. Whereas looking at a response generating process allows for there being multiple influences, variability in the judged magnitudes, that it's much more like a kind of internal sampling process. And then you decide that you've done enough sampling, you've done enough searching around, enough thinking. Often you're only spending 10 or 15 seconds thinking, but you've done enough, you've got to get on. You can't spend the whole time deciding whether to go for option J or option K. You've got the rest of your life to live. So you stop when you've done enough sampling, when you feel sufficiently confident, but it may not be an optimization program. So economists' adoption of analytical mathematical methods with minimal assumptions and the emphasis on tractability, you can understand why they might have done that in the 1940s with John von Neumann and Oscar Morgenstern, when computing power was very limited. But now there's enormous scope for complexity and simulation methods to more closely reflect the very large number of possible influences, even in very simple decisions like those little gambles with a couple or 3 payoffs to choose between and 2 or 3 fairly simple probabilities, and to accept that people's behavior, even in those circumstances, has a number of influences and is going to be essentially probabilistic in nature. That's how human decision processes are. So it's time, I would say, I'm going to finish on this note, to use these modern techniques and modern technologies to put the brain back into Homo economicus, of whichever gender Homo economicus is. Well, I guess that many of us were raised in the traditional way, so that taking on more of this kind of stuff is perhaps more challenging than doing the things that we were raised to do. But on the other hand, I mean, I think there's been a very considerable growth. When Bob Sugden and I sort of started doing our experiments at the University of Newcastle in the 1980s, there was hardly anybody else in the country doing any of it. I think there was John Hay doing some of this stuff. I mean, economists I'm talking about now. Of course, psychologists were doing experiments for decades. But amongst economists, there was John Hay at the University of York. And there were very few others. And now there are quite a large number of universities that have got experimental labs. And there's also been a movement of the kind that we've seen at the University of Warwick. My colleague who's going to speak later, Neil Stewart's a psychologist, but we're both working in the behavioural science department of the business school. And I think that maybe in Cambridge there's a bit more behavioural science going on in the Judge Business School than there is perhaps in the Department of Economics itself. So I'm optimistic that things have come quite a long way, and they've got even further to go. But I noticed that the title of this talk was something about the new orthodoxy. I don't want a new orthodoxy. I don't want a new set of priests replacing the old set of priests. There's enough of those already in the profession. I hope that sort of heterodoxy and innovativeness will mark the development of behavioural economics and experimental economics. So, and I'm optimistic that it will. But it's up to people of your generation to make sure it does. Well, I mean, one of the things I should say is that the types of experiments that I gave examples of are ones where, because you're in a laboratory environment and you're running an experiment, you're trying to keep things under control. We tried to control the probabilities by having a very clearly, simply specified random mechanism, which was the bag with the 100 discs in it that you could pluck things out of. And of course, in the non-experimental world, in the real world, uh, um, many things don't come ready-made with the probabilities printed and a simple mechanism for deciding them. So there's a whole additional area of uncertainty, which involves people having to try and figure out what the probabilities are, what the likelihoods are of certain things happening. And that too can be an important factor. And there's a whole area that I just didn't have time to go into, but which you could look into, which is often referred to as ambiguity. And you can go back to an early paradox that was proposed by Daniel Ellsberg back in the 1960s, which was looking at how people have attitudes to uncertainty, to not being sure about probabilities, and how that's an additional influence on their behavior. And they may be concerned then about additional influences like what if I didn't think hard enough about what might happen? What if I was making my judgment on the basis of my first guess at the probabilities, but if I'd have thought harder, I would have realized that things were more or less probable than I originally thought. And so there's additional scope there for the whole business of how people form their beliefs about likelihoods. And that includes forming their beliefs about the likelihoods of other actors in the economy, other people that they're interacting with, behaving in a variety of different ways. So I really just took the very simplest end of the spectrum, but there's a lot more work to be done in the field of uncertainty and ambiguity. Well, I don't think that we're totally irrational. I think we have different kinds of rationality, and what I think um, Bob and I were trying to do when we were working on things like regret and disappointment is we were saying these are not irrational. If people feel these things, then they need to anticipate that that will be part of the way that they feel, and they need to try and take them into account. So what I think I'm arguing for is not the idea that people um, behave in a completely random way, a scatterbrained way, but that there's a sort of richer notion of what's rational. But you've got to, at the same time, allow for the fact that we have bounded rationality. I mean, the idea of bounded rationality has been around for very many years. Herbert Simon is the person, I guess, who many people associate with it, a psychologist who won the Nobel Prize in the last century for his work on bounded rationality, among other things. And we have to build our models to allow for the boundedness of people's rationality, which is different from supposing that they're just completely all over the place, which I don't think they are. We've got to look for the things that make probabilistic choice move systematically in the way that you saw with that example from Mostella and Noji, that the guy who sometimes chose to play the gamble and sometimes didn't, the proportion of times that he chose to play the gamble moved in a sensible direction. The higher the winning prize was, the more often he accepted the gamble. And it's just that he didn't make the same decision on every single occasion. So it's that kind of level of rationality that I think we should be interested in trying to model in place of the existing highly deterministic and very narrow notions that many economic models use at the present time. One of the things that I should say that seems a little bit sad is that there's much expertise amongst health economists and other economists who've been interested in welfare economics. But although every morning and every evening and every night, it seems that epidemiologists and so-called scientists pop up on our screens, there's been very little reference to behavioural economics or health economics in the current situation. There have been some behavioural scientists, some people with a sort of psychology background, but very little looking at the kinds of impacts that there are on people's income, their employment, their mental health, and those sort of things have not really been, they've not found ways of factoring those things in very explicitly. Clearly there's a tension between economic damage of lockdown and the health benefits, but there's been a great reluctance to address the trade-offs that are involved or think about how one might incorporate the values of the population, the values that they place on freedom of movement, for example, or the values that they place on having a job when this is all over into the analysis. And the one other thing I'd say is that some of us who've been working in the field of health and safety in particular have struggled with which ways that we can ask questions, which procedures we can use to elicit values or preferences from people that we can relay to the government departments or government agencies like the Health and Safety Executive to give some sort of measure or indication of how important these non-marketed benefits are. But one of the things I guess we learn from behavioural economics and experimental economics is just how dependent the answers to a number of these questions are on the way in which the questions are asked, and how important it is when you're undertaking these surveys to put in checks and cross-checks to see whether you're getting answers that are seriously influenced by the nature of the question rather than the thing you really want to find out, which is the nature of the underlying values of the people in the population who are being affected by these decisions.